So solving an equation with two radicals does get a little bit more complex, and the question does get longer, but it's nothing that we can't handle. So as with the other two, when we had only a single radical, we needed to get the radical by itself. Now that we have two radicals, we need to get one of them by itself. And it doesn't matter which one, but I'm going to pick getting 5x, square root of 5x plus 4 by itself. So to do that, I need to move this 5, subtract 5 from both sides. Leaves us with 2 plus root 3x equals square root of 5x plus 4. So now that we have that root by itself, we can square both sides. It will cancel the root that's by itself, but it will not cancel on the left. Just as with example 2, we do need to FOIL out. This is something that we would have looked at in 6.3, except it would have been given already like this in a format to FOIL. So firsts, 2 times 2, 4. Outsides, 2 times root 3x would be just 2 root 3x. Insides, root 3x times 2 would be another 2 root 3x. And the last, root 3x times root 3x, would be root 9x squared. A little bit of simplifying, combining some like terms. 4 is going to be 4. We have two sets of 2 root 3x. 2 plus 2 would be 4 root 3x. And the root 9x squared, I'm just going to deal with up here. We can simplify that. Prime factorize the 9, it's 3 times 3. X squared is x times x. We have a pair of 3's, also a pair of x's that can come out, so we'll have a 3x coming out. Nothing left under the root, so it's really just 3x, which still equals 5x plus 4. So now we've taken this equation from having two radicals in it, now we only have the one, it's right here. Now that we have one, we can isolate it, square both sides again, and go at it from there. So to do that, we'll need to subtract 4 from both sides. We'll need to subtract 3x from both sides. And I'll just finish that on the next slide. So we have 4 root 3x on the left. And on the right, all that we'll have left is 2x. We can't jump to squaring both sides yet. We don't have that root totally isolated. Divide both sides by 4. Now we have just root 3x on the left. On the right, we would have 2x over 4, but we can reduce that to x over 2. Now we can square both sides. Cancels out the root on the left. So we get 3x on the left equals, and to square a fraction, square the top, square the bottom separately, we get x squared over 4. We have another quadratic equation, so we do need to get one side equal to 0, but we also have x squared over 4, which does complicate things. So getting rid of the fraction would actually be a good place to go right now. Cross multiplying will do that. We'll put a 1 under here. 1 times x squared is x squared. 3x times 4 is 12x. And because this is a quadratic, we need to have a 0 on one side. So easiest thing to do is subtract 12x from both sides. We get x squared minus 12x on the left, which equals 0. Now it's not a trinomial, so standard factoring of adding to this and multiplying to that doesn't work, but in reality it does. Because we have x squared minus 12x, we have no constant term, but really it's a 0. We could also think of this on the left as having a common factor of x that we can take out. When we do that, we have x minus 12 left. From here we can split, and we have that x equals 0, or x minus 12 equals 0. X equals 0 is dealt with, x minus 12 equals 0. We have to add 12 to both sides, so we get x equals 12. Not quite done yet. We still have to check both of these answers out, which I'll do on the next page. I'll go with x equals 0 first. Go back to the original equation, plug in 0 for x, so we get 7 plus, it was square root of 3x, so I'll have 3 times 0. Does that equal, it was the square root of 5x plus 4, so 5 times 0 plus 4, plus 5. So left we have 7 plus, under the root, 3 times 0 is 0, and the square root of 0 is also 0. Under the root on the right, 5 times 0 is 0, and 0 plus 4 is 4, so we have square root of 4 plus 5. Now we could go one step further and actually write out that the square root of 4 is 2, but at this point it should be relatively obvious that both sides will work out to 7, and that is enough for the check. As long as we're absolutely certain that they will work out to the same, we can stop the check here and say we're confident in that answer. We do need to check the other one. Just because one answer works does not mean the other one won't. We could have two valid answers here. So we'll plug in 12 for x. So on the left, 7 plus, and 3 times 12 is 36. Under this root, 5 times 12 is 60, and 60 plus 4 is 64. Same type of situations where we left off the last check, but I am going to go one step further. So 7 plus square root of 36 is 6. Potentially equals square root of 64 is 8 plus 5. And at this point it should be quite obvious that both sides work out to 13. So in this case both answers actually do check out. Just because you get two answers does not mean that one of them won't check out or all of them will check out. There's no way of knowing without actually doing the checks.